Hi guys, welcome back to the channel. So today we are going to be solving today's lead code question, which is boats to save people. So we are given an array of people and then we are given the limit, and then we need to find the minimum number of boats required to carry every person which are present in this particular array. So the people of I represents the weight of this particular I person, and then an infinite number of boats are present where each boat can carry maximum weight of limit, and then each boat carries at most two people at the same time, provided that sum of the weights of those people is at most limit, and then we need to return the minimum number of boats we need to carry, minimum number of boats required to carry each person which are present in this particular array. Suppose let us take one particular example where we have 1 2 and then limit equal to 3. Now there is two three conditions. One condition is like each boat can carry at most two people. That means it can carry it can carry two people. These are the two possibilities. And then one more thing is the sum of those peoples which are present in the boat should always be less than or equal to limit. That means we need to consider the people such that the sum of those weights should always be less than or equal to limit, and then we need to return the minimum number of boats that we need to carry, that we need to use to carry every person which are present in the people. So suppose if I use 1 2, then we are going to return 1. Why? Because in one boat we are going to include the person with the weight of 1, and then we are going to include the person with weight 2. And then let us take one more example where we have people as 3 2 and then 2 and then 1, and then we are given limit equal to 3. Now for this particular case we need to make sure that we will use minimum number of boats to carry every person. So for this, if we take 3 as limit, then we can consider 1 2 as our as our first answer, and then we can pick only 2, and then we can pick only 3, and then for this we are going to use 3 boats. And then if we come to the 3 5 3 4, for this we are going to use 3 and then 3 and then 4 and then 5. These are the four boards which we are going to use. Suppose let us take one example and try to figure out like how we are going to solve this particular question. Suppose let's say I am given 1 and then 1 and then 2 and then 2 and then 3 and then 4. So let us take the limit as some extra value which is going to be like, which is going to be limit is equal to 100. So if I consider limit equal to 100, then I can consider two possibilities. One is going to be 3 4. I can have different possibilities, but suppose let's say the maximum weight which we can take for this particular boat, which is going to be 3 and then 4, so which is going to be 7, and then the minimum weight is going to be 1 plus 1, so this is going to be 2. Instead of considering the maximum weight and the lowest weight, we are going to pick the weight such that it will include the minimum weight as well as the maximum weight, so that we'll left with the minimum gap which is present in the boat. So that I'll pick 4 and then I'll pick 5. I'll pick 1, so that the leftover weights will have that particular difference, so that it will match with the another boat. Suppose if I consider 3 4, which is going to be maximum value, and then if let's say let's take one more example where limit equal to 7 7 or 6. So for this I cannot pick 3 4. So if I pick only 4, then it is going to consume 1. And then if I consider 1 4, then I'm going to consume only one boat which is present, which we are going to use for these persons with the weight of 1 and then 4. So for this, what we are going to do is we are going to sort, and then we are going to use this particular sort, and then we are going to take this particular person which is to the rightmost, and then if we have any weight left, that means if we can use this particular left limit which is present with the weight, if we can use, then we can use. If we cannot able to use this, then we'll increment the number of boards, and then we are going to use the number of boards which are present in the array, and then we are going to return the answer. So let us see how we are going to solve the question. So first we are going to sort the array so that every people will be arranged based upon their weights, and then L is going to store the low, and then right R is going to store the right, and then we are going to take the boundaries, and then we are going to assign the number of boards equal to 0 and then weight equal to 0, and then we are going to do the traversal like left is less than or equal to R, and then we are going to pick the weight which is going to be people of R, which is going to be the rightmost people, and then we are going to decrement this R, and then when we say weight plus people of L is less than or equal to this particular limit, that means we can use the right person which is present in the array, and then we can pick the left person which is present in the array, and then we are going to increment the low plus plus if it is in the limit. If it is not in the limit, then we are not going to consider the left guy which is present in the array, and then we are going to increment the number of boards, and then at last we are going to return the answer. So if we come to the time and space complexity, the time complexity is going to be big of n. Why? Because we are traversing the whole array. And then if we come to the space complexity, we are not using any extra space. That's why it will be big of 1. And then it is big of n for only doing the traversal from left to right, or for doing the traversal. And then one more thing, we are sorting the array. So for that we are going to consume n log n time complexity. Yeah, that's all for this video. Thanks for watching the video.